Hello, my math students. What we're about to do, 2.3, this is from Probability and Statistics. So for my Probability and Statistics class, this is a review of the highlights. And for Algebra 2, the end of your curriculum includes a Probability and Statistics unit. So we're going to go ahead and do an introduction to the basics. So 2.3, measures of central tendency. That's mean, median, and mode, which you guys have worked with before. The mean, a measure of central tendency, is a value that represents a typical or central entry of a data set. The three most commonly used measures of central tendency are the mean, median, and mode. The mean of a data set is the sum of all the data entries divided by the number of entries. So your mean is the average. Population mean, and sample mean. Okay, so in statistics, we deal with populations and samples. A population includes everybody or everything that you're concerned with. So for example, if I wanted to find the average GPA of Winter Park High School students, if I was using a population, that means I would have to include every single Winter Park High School student to come up with the population mean. If I was running short on time or I just didn't have the means to get to every single student, I could take a sample. So that would be a portion of the population. Maybe I could, look at 100 students at Winter Park High School and average those 100 grades to come up with a sample mean. Okay, so a population involves everybody at the school, where a sample would be a portion of the students at the school. Okay, and we hope that our sample gives us a good representation of the population. So population mean is mu. Okay, it looks like, this is a Greek symbol. It kind of looks like a cursive M or a U put together. Mu is the symbol that we use for population mean. A sample mean is an X with a line on top of it, and it's called X bar. The uppercase N represents your population size, and the lowercase n represents your sample size. And the X's are your data entries. Both probability and statistics students and Algebra 2 students, you guys know this symbol is sigma, and that means sum. So whenever we see that symbol, we'll be adding. So even though the symbols for population mean and sample mean are different, we're doing the same thing. Okay, so you take the values of your data and you add them up and you divide by the number of data entries. Okay, so that's what you're doing for both population mean and sample mean. An example, the following are ages of all 7 employees at a small company. So 1, 2, 3, 4, 5, 6, 7 data entries. To calculate the population mean, and this would be a population mean because we're using all of the employees, small company, only 7 employees. To calculate the population mean, we're going to get mu by taking all of your data entries, finding the sum of them, and dividing by the number of entries. Add the ages and divide by 7. Okay, so when we add up all of the numbers, we get 343. Divided by the number of employees, 7, gives us an average of 49. The mean age of the employees is 49 years. Median. The median of a data set is the value that lies in the middle of the data when the data set is ordered. Okay, so that's important. If the data set has an odd number of entries, the median is the middle data entry. If the data set has an even number of data entries, the median is the mean or the average of the two middle data entries. Okay, so now we're going to calculate the median age of those 7 employees. The first thing we need to do is order the data from least to greatest. Now that it's ordered, we would pick the middle data entry, which is 53. The median age of the employees is 53 years. Mode. The mode of a data set is the data entry that occurs with the greatest frequency. Okay, so mode is the number that appears most often. If no entry is repeated, the data set has no mode. If 2 entries occur with the same greatest frequency, each entry is a mode and the data set is called bimodal. Okay, so it's possible for a data set to have 0 modes, 1 mode, or 2 modes. For our example, we're looking at the ages of our 7 employees. And 57 appears twice. So because 57 is the number that occurs most often, 57 is your mode. An outlier is a data entry that is far removed from the other entries in the data set. Okay, so here's our example. We had our 7 employees. A 29-year-old employee now joins the company, and the ages of the employees are now 53, 32, 61, 57, 39, 44, 57, and 29. So we have 1, 2, 3, 4, 5, 6, 7, 8 employees. We need to recalculate the mean, median, and mode. Which measure of central tendency was affected when this new age was added? Okay, so we're going to recalculate the mean. So if I add up these 8 numbers and divide by 8, the mean is now 46.5. If we rearrange this least to greatest, our median is 48.5. Okay, and that would be an even number of terms. So you wouldn't have just the one middle term, you would have 2 middle terms that you would have to add together and divide by 2 to get the 48.5. And finally, the mode is still 57 because that's the only number that repeats. So the mean takes into account every value, so it gets affected by an outlier. Your median and mode are not influenced by extreme values. You can see that your mode didn't change at all, and the median changed a little bit, but the mean is the number that got affected the most by that outlier of the 29. Okay, so now we're going to talk about a weighted mean, and it's an average. A lot of your grades are weighted means because you have different categories like tests and quizzes, homework, classwork, and they have different percentages for each category. That's a weighted mean. So if you were ever trying to figure out like, what do I need on the next test in order to get this grade, knowing how to work through this formula would be really helpful. A weighted mean is the mean of a data set whose entries have varying weights. A weighted mean is given by this formula where I have x bar, which is my sample mean, and we're going to calculate that by doing our x's times their weights. And once we get those products, we'll add them up, and we're going to divide by the sum of the weights. Okay, and it tells you where W is the weight of each entry, which is X. Here is our example. Not seeing the whole page. Okay. Grades in a statistics class are weighted as follows. Tests are worth 50% of the grade. Homework is worth 30% of the grade. And the final is worth 20% of the grade. A student receives a total of 80 points on tests, 100 points on homework, and 85 points on his final. What is his current grade? Begin by organizing the data into a table. I would not skip this part. So you're going to have your categories here, tests, homework, final. And the problem told us that we had 80 points in the test category and 100 points for the homework category and 85 points in the final category. Each of those categories was assigned a weight, and test was 50%. Make sure that you change your percentages to decimals. So you're going to move the decimal 2 spots to the left to go from a percent to a decimal. The weight for tests is now 0.50. The weight for homework is 0.30. And the weight for the final grade, the final exam, is 0.20. Okay. In our formula, it said that we had to do the x's times the w's. So that's what we're doing here. 80 times 0.50 gives me 40. 100 times 0.30 is 30. 85 times 0.20 is 17. Okay, so when we take these products, the x's times the w's, you need to add them. Okay, sigma means we're adding. 40 plus 30 plus 17 gives us the 87. And the sum of your weights, since they left this as a decimal, I would have put a 1 here because it would be 1.00. But it looks like they changed it back to a percentage, 100%. So then when you divide the 87 by 100, it gave us 0.87, which when you change it back to a percent would be 87%. But if you had just done the 87 divided by 1, it would have left it as 87%. So just pay attention to how the question is asking for the answer, whether they want the answer in decimal form or as a percentage. The mean of a frequency distribution for a sample is approximated by this formula. Okay, so we have another type of a mean, and this is a mean of a frequency distribution. We've got x bar, so our sample mean. We're going to calculate that by doing our x's, so each data entry times its frequency, which is f. And once you get all of those products, you'll add them up and divide by the number of terms in your sample, which is lowercase n. N, the number of terms in your sample, is equal to the sum of your frequencies. F is for frequency, where x and f are the midpoints and frequencies of the classes. Okay, so once we do an example, it'll be easy. Following the frequency distribution, let me start over. The following frequency distribution represents the ages of 30 students in a statistics class. Find the mean of the frequency distribution. So sometimes data is presented in classes. So here, the data is grouped together, and the ages, this is saying anyone from 18 to 25 would be in this class or this group. And then anyone ages 26 to 33 would be in this class or this group. And then the next class is people who are ages 34 to 41. And the next class is people ages 42 to 49. And the next class is people ages 50 to 57. And they went through this statistics class and took everybody's age. And the F is the frequency, or how often somebody fell into this group, this category. So 13 of the kids or adults in this class were ages 18 to 25. 8 people in the class were ages 26 to 33. 4 people in the class were ages 34 to 41. 3 people in the statistics class were ages 42 to 49. And 2 people in the statistics class had an age that ranged from 50 to 57. Okay, so the classes, that would be given, and the frequencies would be given as well. Okay, and remember the previous slide said that in your sample size is the sum of the frequencies. So you could add 13 plus 8 plus 4 plus 3 plus 2, and we get those 30 kids or 30 adults in the class. In order for us to use the formula, though, we need an X times F. And X isn't given, but X is representing your class midpoint. So in order to find your class midpoint, you're going to average these two numbers. 18 plus 25. Take that sum and divide it by 2 to get your class midpoint of 21.5. So the middle age between 18 and 25 is 21.5. And you would do that for all of the classes. So we need to find the average between 26 and 33. We would add those two numbers, divide by 2 to get 29.5. We'll average 34 and 41 to get 37.5. Okay, so we've got all our class midpoints. Those are your X's. The frequencies are given. And to use the formula, we need to do X times F. Okay, 21.5 times 13 gives us this product of 279.5. Then you would do the next midpoint, 29.5, times its frequency, 8, to get 236. We'll multiply again. 37.5 times 4 gives us 150. The next midpoint, 45.5 times 3 gives me 136.5. Our next midpoint, 53.5 times 2 is 107. The next thing in the formula, we need to find the sum. So when you see sigma, that means you're adding. Those numbers get added up and we get 909. Okay, so we did the multiplication and we did the X times F. Here are my products. The sum, we added them. So this numerator is 909. N is the number of terms or the number of people in your sample, which we got by adding up the frequencies, 30. And finally, we can divide the 909 by 30 to get X bar, our sample mean, of 30.3. The average age of the class is 30.3. Almost done, guys. The rest is easy. Shapes of distributions. A frequency distribution is symmetric when a vertical line can be drawn through the middle of a graph of the distribution, and the resulting halves are approximately the mirror images. Okay, so symmetric is the same on both sides. A frequency distribution, which is similar to a bar graph, is uniform, or it has a rectangular shape when all of your data entries or classes in your distribution have equal frequencies. A uniform distribution is also symmetric, because if you split it in half, it's going to be the same on both sides. Okay, and then we have two more shapes of distributions. A frequency distribution is skewed if the tail of the graph elongates more to one side than the other. A distribution is skewed left, or negatively skewed, if its tail extends to the left. A distribution is skewed right, or positively skewed, if its tail extends to the right. Okay, so we're going to look at shapes of these graphs, and it'll be really easy.